So when we talk about domain, we're basically talking about all of the x values. And when we're talking about range, it's all of the y values. Okay, now, another word for domain and range, right? Another word for these variables is the x values that are included in the domain are also called the independent variable. This is the variable that represents the domain. So, like it could be x, it could be t, whatever. So basically whatever is on the horizontal axis. And then the dependent variable is the variable that represents the range. So that will be whatever's on the y-axis, right? So when you're talking about, x and y, it'll be dependent x, independent x, dependent y, or it could be, let's say, time and velocity, right? So whatever's on the x-axis is the independent variable. All right. When we're talking, okay, this is so important because even in like pre-calculus and even in calculus, sometimes I have to correct students. When we're talking about domain and range, we always write it in ascending order, right? So from the smallest up, okay? All right. So there you go. So we want to state the domain and range of each relation. Then we want to determine whether each relation is a function. So first, let's do domain and range, right? So here, to write the domain, basically you want to write all of the x values for which there is a graph, right? And we put them in these curly brackets. And so look at each of these points. You have one point here at x equals -4. So -4 is included in the domain. Another point with x equals -3. Another point with 0, 1, and 3. So these are the x values of all the places where there is a graph. Okay? Now, the range is going to be all the y values for which there is a graph. And you notice for the domain, I started at the very left because this is where all the small numbers are. And for the range, I'm going to start at the very bottom because this is where all the small numbers are. Now, so look at y equals -2, right? You've got 2 points at y equals -2, correct? In your domain, you only show that, in your range, you only show that once. So -2, and then what else? 1, 2, and 3. Okay? Now, how do you figure out whether or not it's a function? The easiest way, if you've got a graph, is the vertical line test. What that means is if you draw a series of imaginary vertical lines through the graph, each vertical line should only cross the graph once. So for example, if I draw a line there, you see how it only crosses the graph at one point, right? And if I do that everywhere, each of the vertical lines will only cross the graph one time. That means yes, it's a function. Okay, so here, let's do domain here. This is actually even easier. You can just look and just list all the different values. So we're going to do -2, -1, 1, 2. We don't repeat. So for the range, -1, 1, 0, 1. Okay? The range is all the y's. Now, is this a function? When you've got a table of values like this, the way to figure out if something is a function is see if there is a repeated x value, but you also have to make sure, so here, there is a repeated x value, correct? Now the next one is, do each of those -2's point to a different y? Yes, that means this is not a function. Yeah. Oh, what was I supposed to write?
It's just -1, it's negative.
Oh, sorry. No, I didn't mean to do that. Sorry. It's -1, 0, 1. Okay? Any questions? Yep. It's because this is set notation. You'll learn. This is like you can practice. Like if you're ever, like in a car ride. This is the notation for. This is the notation for like a set, like a domain or a range, like all the values of a function. It will be wrong if you do parentheses. Okay? Nope. Curly brackets. Because each of these means something else. So do curly brackets. Listen, it doesn't have to be as pretty. Just make it a curly bracket. Yes. Yeah.
In A, what do you mean that it only crosses through the
So look at each of the purple vertical lines, right? Okay, so that when I say graph, in this case, it's the points, the individual points. So do you see how each of them crosses once? Yeah. Okay.
Does it only have to, can it only be vertical lines?
Yes, vertical lines. This is called the vertical line test. Okay, so here, domain, right? Look at all the x values, right? But you have to put them in ascending order. So -3, -2, 3, and 4. And then the range, what do you have? We have -5, 5, -2, -2. So it's -5, -2, 5. Okay? Now, is this a function? Do any of the x values repeat?
No.
No. So it is a function. Okay. So here, what's the domain going to be? You can call it out. What do you think for this next one? Yeah. And then the range is going to be 0, 1, and 3. Okay. Now, let's see if this is a function. What do you think? No.
You can't just look at it and see that there's two same x.
Exactly. That's all you have to do.
You have to write domain and range.
Yeah, because so the question is asking for domain and range, so it's like an A and B. Part A is asking for domain and part B is asking for range. And you see how the x repeats, but they have different values? That means this is not a function. Okay, so here is a description of the vertical line test, right? So it's got to be just vertical lines, and if it only passes the graph, if the vertical lines pass the graph at only one point, it's a function. But look at this one. This imaginary vertical line crosses the graph at more than one point, so this is not a function. Okay? Now, let's go ahead and go to the calculator. Open up your calculators. Okay? So turn on your calculators and okay. And go to the graph. Okay? Okay, so for some of these, you might be able to do it in your head, but right now I just want to practice like some of the graphing functions, right? Huh?
It doesn't have any. It doesn't have a setting.
Okay, sorry, I went there by accident. So this is what you guys have. Okay. What I want you to do is press the tab button, which is highlighted in red on my screen. And you'll get this. It says F1. For F1, you're going to put in the function, whatever comes after here. Okay? So now listen. It's 1/2 times x minus 5. So you have two options of how to do this. If you want to put in the 1/2, it's got to be in parentheses. 1/2 x minus 5. X is all the way at the bottom. Minus 5, like this. Okay? So it's 1/2 times the x minus 5. And when you press enter, you should have a graph that looks like this. Huh?
I did it normally.
Okay, so you have a CIS, which technically we don't allow in the school. So when we're taking a test and stuff, I might have to like do something else. But that's why. In general, it is always a good idea to be aware of where the parentheses should go. Okay, yes.
I put the parentheses, and then I also didn't, but I don't have a CAS.
Okay, okay, hear me out. Always put the parentheses because there will be times where the graph will, like the calculator will not understand you, or it will not understand what you're talking about. Yes. Okay, I'll come over in a minute. Okay, so let's talk about domain and range for this one, right? Okay, another thing you can do if you want to see, you know, more of this graph, press menu here, menu, and you can either press the number 4 or scroll down to 4, Windows Zoom. And again, you can either press 4 or scroll down to 4 and say zoom out. Now it asks you where you want the center to be. Just, you know, put the cursor anywhere and just click the center button. Maybe like in the center of the window, right? So do you see how it zooms out for you? Okay, so you can see that this function is gonna, you know, stretch forever in both of these directions, right? So for domain and range, what do you think this is gonna be? For domain and range, we have to find all of the x values for which there is a graph, okay? Is there ever a point where the graph will stop for this one? No. So the domain is actually all real numbers. So we can say domain is all real numbers. Because there is never a point where the graph doesn't exist, right? For all the x values, if you go across, there is always a graph. Okay, and the range, same thing. It'll be all real values.
We have to put the parentheses for these?
No, all real values is just, okay. Another way to do it is you can say, or actually I'll talk about the other way in a second. Okay, let's go ahead and graph the other one.
Wait, why is it all real numbers?
Okay, so the way we're talking about domain and range is this. So look at all the x values here, right? If you go along the x-axis, is there ever a place where there is no graph? Like if you're here, there's a graph down here. If you're here, there's a graph down here. If you're here, there's a graph up there, right? That's why there is a domain of all real numbers. Same with the range. No matter where you are, if you're here, there's a graph there. If you're here, there's a graph there, okay? All right, so to graph the other function, here's what you're gonna do. Press tab again and press the up button to go to your graph, to go to your previous function. You can do Control Delete and it'll just delete the function, okay? And what was it, x squared plus 4? So go ahead and type in x squared plus 4 and you should get a graph that looks like that, okay? Now, try to think about what the domain and range is for this one. Okay. So it's not broken. We're gonna go to menu, 3, 1, here. Okay?
Something happened, like, I pressed tab and then delete, and then like this.
Okay, so you press delete one too many times. So let's go to 1, 2, 1, okay. So let's delete all these. You don't like the things to that. You don't need that now. Okay, so take a look. Take a look at all, okay, so this is gonna expand everywhere, okay? So no matter where you are on the x value, you're gonna have a graph somewhere above or below the x-axis. So the domain is gonna be all real numbers. The range, right? Look at the range. Is there a graph if you're here? No, it only starts at 4 and goes up, right? So it's gotta be y for the range. Y is greater than or equal to 4. Okay, now, go back. Okay, so go back to menu. Let me show you how to get it back to the original zoom. Menu. Number 4 is window zoom. And you see how number 5 says zoom standard? That's the standard window, like the default window. So press that one and you'll have this. Okay? Yes, and then the other Lexi.
For the first two, do you put it as a function?
Yes. Was the first one a function? Yes. So yes, it's a function. And is this a function? No? Why not?
It's a parabola.
If you draw a series of vertical lines, it will pass the vertical line test, so it is a function. Okay, let's go ahead and graph the other one. Tab and go up. Okay, if you keep pressing delete, 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 you might run into trouble because it deletes more than you want. So the best way is to do control delete. That way it'll just delete the function in one step. So x, this bottom x, to the power of 3. So this, it's called a caret button, right? To the left of the 4. 3. So when you do x to the power of 3, press the left or the right arrow button, -1. Okay. Lexi, did you have another question?
I was just gonna ask if we're
For sum. Now look, later on in this chapter, we're going to become experts at graphing most of these things, right? So for those, no, right? So, okay, so whatever you haven't learned how to graph yet, if you need to graph it, you'll have a calculator, or I'll just give you the graph. Okay, so take a look at this, okay? First of all, domain and range. So this extends forever, right? Upwards and outwards. So what would domain be? All real numbers. And what about range? All real numbers. Now, is this a function?
Wait.
I don't know.
If you,
No.
okay. So we said this is expanding, right? And if you draw a series of vertical line tests, it will pass the vertical line test. So it is a function. Okay. Very quickly, and then I have to move on to the...
When I put -1, it only doesn't fit. You have to press like the arrow.
Okay, so when you put the 3, you had to press the right arrow to exit out of that, and then... Okay, so look at the next one. The next one is a little bit different because as opposed to these where it was all y equals, y equals, y equals, this one is now x equals. So in the graph, right, when we're putting it in the graph, remember it was like f1 of x. This was f of x, which means y. But now this says x equals 2, not y equals 2. So I have to make some modifications on how to put it in my calculator. So here's what we're going to do. Go to menu. Number 3 is graph entry edit. You're going to select the second option, which is relation. When you do that, you'll get something like this. Relation x comma y. This is what a lot of you were getting when you press delete too many times. Here, you can put in all the variables that you want. So we're literally going to type in x equals, okay, and then 3.
Oh, 2.
Oh, is it 2?
Yeah.
Oh, I didn't delete the other one. Isn't that cool?
I wish we could do this one on the calculation thing. It's so much easier.
Okay, so what's the domain here? Let's ignore this one. What's the domain?
2.
If we're here, is there ever a graph? The only place that there is a graph is at x equals 2. So domain is just 2.
It says test restriction. This functionality is restricted in test.
Okay, I'll come over in a second, okay? I'll come over in a second. Okay, so what about the range?
Oh, it's
All real numbers. Is that a function?
No.
Definitely not. Okay, I'm going to show you another way to write all real numbers. So all real numbers basically says, right, on the x-axis, so if I have some function that looks like this, okay, on the x-axis, you could go all the way to negative infinity and there will be a graph. And on the y, and on this side, you can go all the way to positive infinity and there will be a graph. So another way to write it is, you can say negative infinity less than x less than infinity. Okay? That's another way to do it. But for the y, you would do negative infinity less than y less than infinity. You cannot do less than or equal to because we don't know where infinity is. We can't ever get there. So never equal to. Okay? Yeah.
Can you do the domain and then the colon and then the curly bracket with negative infinity?
Yeah. Yeah. Okay. So discrete versus continuous relations. A discrete relation is when you have just individual points, like discrete. We're not like, it's not like secretive, right? Not that type of discrete, just individual points. Continuous is when you have, you know, a line, a curve, whatever. All right? Yes. Okay. So, function notation. Okay, f of x just means y. So if you have an equation of a line, you can express it in function notation like this. All right? So if you have, let's say, y equals 2x minus 3, another way to write it is f of x equals 2x minus 3. Now, if I ask you, what's f of negative 6? What I mean is, what is the y value when x is 6? So, if I have f of negative 6, what I mean is, what is the y value when x is negative 6? Okay, so f stands for y, negative 6 is for x. So I plug negative 6 in there, and it'll be 2 times negative 6 minus 3, which is what? Negative 15. Okay? All right, so f of negative 2. Here, take a look. I've got f of x and g of x. Let's do f of negative 2. 2 times negative 2 squared minus 3 times negative 2 plus 1. Who can tell me how much that is?
8 plus 6 plus
23? No, this is 8.
15.
15. Okay. Next I have f of 3a. Now, instead of the x, right? So remember, this is the y. This is what goes into the x. So in my function, wherever I see an x, I'm going to replace it with 3a. So 2 times 3a squared minus 3 times 3a plus 1. Okay, we're really getting into some algebra here, okay? Who does this square belong to? The 3 and the a. So this is going to be 2 times 9a squared minus 9a plus 1. 18a squared minus 9a plus 1. Okay? and that's it. Now it's simplified. Okay, let's do g of -1. Now my function is g, it's the other function. So I'm going to plug it into the g function. So 5 over -1 plus 2, 5 over 1 is 5. So we did this in the chapter 1 test, but it was like, okay, if x is, if, you know, like now we have like grown-up notation. Okay, f of b minus 3. Here's the good stuff. Instead of each x, we're going to put in b minus 3. 2 times b minus 3 squared minus 3 times b minus 3 plus 1. Okay. This is so much fun. 2 times. I gotta square this. Okay, look up here. Whenever you're squaring a binomial, b minus 3, b plus 3, whatever, square the first number, b squared. Square the last number, positive 9. In the middle, I get 2 times -3 times b, -6b. Okay, I'll go over that again in a minute. Now, distribute the -3. -3b plus 9 plus 1. Okay, go ahead and simplify that for a minute. Okay, so, anybody? So what happens here? 2b squared minus 12b plus 18 minus 3b plus 10. And so altogether, how much is that? All right. Okay. Now, look at what I have here. 2 times g of a. 2 times g of a. So it's like this. 2 times g of a. I do 2 times. Now, what's g of a? It's basically g, but a instead of all the x's. So it'll be 5 over a plus 2. Okay? Now, this is technically 2 over 1. So what we do is we multiply numerators and denominators with each other. So it'll be 2 times 5, 10 over a plus 2. Okay? Next one. G of a half. So what was g? 5 over x plus 2. So it's going to be 5 over 1/2 plus 2. Okay? So this is 5 over 2, right? Which is 5 times 2 over 5. And since this is over 1, this will be just 2, right? The 5's go away. So did we use a calculator for any of this stuff? No, right? So you shouldn't need a calculator for any of this stuff. Okay? Yeah.
D, how does it b squared minus 6b plus?
I'll go over that in a second. Let me do this. Okay. If g, okay, look at this one. Now this is different. It's saying g of x is 4. So let's translate that into a different sentence. G of x, what was g of x? 5 over x plus 2. G of x is a 4th. You see how different this is? Now we got to solve this, right? We got to find the value of x. So I cross multiply. Yes, there is more than one way. And, but I want you to be comfortable with all the ways. X plus 2. So how much is x? 18. Okay. All right. So we're going to do the next page too, and then I'm going to go over squaring again. Okay, the next page is super quick. Okay, so basically, how do we know whether something is linear or not? All right. A big thing in math is if you are thrown a random function, you should be able to figure out what that looks like, right? And we're gonna start here and gradually learn all of them. Okay, so first let's talk about linear relations. Linear relations give you straight lines when you graph them. Y equals mx plus b, okay? Now, it's easier to say what is not a linear function sometimes, right? So linear equations cannot have powers of variables other than one, x squared, y squared, cubed, blah, 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 whatever. Square roots of variables, no root x, no root y. You can have root 3, but no variables. You cannot have variables in the denominator, 1 over x, 2 over y. You cannot have products of variables, okay? So take a look at this one. Okay, so these are all linear, okay? X to the 1, y to the 1, blah, 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 blah. Here, there is a y squared, not a linear function. There is a root x, not a linear function. You've got x times y. You've got 1 over x, right? All of those fail. Okay, so these should be like, very quick on a test or a quiz. So the first one, is it linear or not? Yes. Second one? Nope, because of the x times y. Third one? Fourth one? No. Fifth one? No. Sixth one? Oh, no. Okay? That was easy. That's like, 90% of lesson 2. Okay? X and Y intercept. Okay. So, X and Y intercept, right? If you have this is the X intercept, right? What's the Y value there? 0. Okay? So, when you have X intercept, the Y value has to be 0. So you're going to have a number for X, comma 0. Here is the Y intercept. What's the X value there? 0. Y intercept has to have a number for the Y. Has to have a number for the Y, if I can erase that, and a 0 for the X. Okay? So, let's find X-intercept. We say let Y equal 0, because for X-intercept, Y is 0. Okay, so 2 over 3x minus 2 times 0 is negative 6. 2 over 3x is negative 6. Multiply by 3 over 2. 3 over 2. X is negative 9. But your answer has to be written like this. Okay. For y-intercept, we say let x equal 0. So if x is 0, it goes away. So you just have negative 2y equal to negative 6. Y is 3, 0, comma 3. So in at-level algebra 2, I will say, write all this out. In honors algebra 2, I want you to know that you can skip the 2 times 0 and just exclude it, right? So let's do y-intercept and x-intercept here. For x-intercept, y is 0. So I get 0 equals 1 over 3x minus 4. Bring 4 to the other side. What's x? Yep. So how do I write it? Yep. Okay. Okay, stop for the y-intercept. What form is this? Slope-intercept form. So already this is y equals mx plus b. Already this is the y-intercept, isn't it? So don't do any work. Y-intercept is just 0, comma, -4. Okay? Right? Because it's y equals mx plus b, and it's this one. Okay, let's go over, I'll just do it here. Let's go over some binomial squaring. Okay, this is the best thing ever. Okay, so let's do this. If you have x plus 4 squared, okay, one thing you can do is x plus 4 times x plus 4. You FOIL, and you get x squared plus 4x plus 4x plus 16. And then that becomes x squared plus 8x plus 16. You guys know how to do this, right? Okay. In honors classes, we don't want to do this because we need to learn. Julian, are you with me? We need to learn, okay, how to do it just mentally very quickly without this. So we got to do it using the shortcut. Here's how we do it. Oops. Oh, sorry. Okay. Square. This was supposed to be x plus 4. Okay. Square the first one, x squared. Square the last one, what do you get? Positive 16 every time you square. Now, there has to be a middle term. Many students just go, oh, it's x squared plus 16. No, there has to be a middle term. It's this exponent, 2, times this number, 4, which is how much? 8, times this number, x. So positive 8x. Now let's do a negative one. X minus 9 squared. Square this one. Square this one. What do we get in the middle? Negative 18x. Okay, so if I were to give you, if I were to give you this.
Oh, wait, I'm sorry. That's 81 to y6.
If I were to give you, or not, no more. Okay.
Sorry.
If I were to give you this, you have to just look at it and say x squared minus 16x plus 64. Just like that. Okay? This is, because things get so quick that the quicker you are at these things, the more time you have to focus on the bigger things. Okay? All right.